In this video, we're going to look at how to add, subtract, multiply, and divide functions, and then also evaluate those combinations of functions for specific values. Now, let's say we have three functions, f of x, g of x, and h of x. There's several different ways we can combine these functions. We can add, subtract, multiply, or divide. There's also one more way which I'll discuss in another video. Now, most of the time, you're going to see what the request is, what you're required to do to the functions written in this form. So, for instance, f plus g of x means you take f of x and plus g of x. Or f minus g of x means f of x minus g of x. This one is multiply, means you multiply the two functions, or this one, divide. Now, one thing to know is that sometimes you will have certain values that won't work, certain x values that give you an undefined result, especially with the division ones. So I'm also going to talk about how to find restrictions in your domain. So let's take those original functions, which were, again, these three here, and we're going to perform certain operations with it. So f plus g of x means I'm going to take f of x, which is x squared minus 8x plus 4. I'm going to add that to g of x, which is 4x minus 3. It's a good idea to put your functions in parentheses because on some of them your order is going to matter. Order always matters, but also sometimes, especially on the next one, you might have something you're having to distribute, like a negative. But for this one, all you're doing is combining like terms. So there's only this x squared, so 1x squared plus 0x squared gives me x squared. Negative 8x plus 4x gives me negative 4x, and 4 plus negative 3 gives me 1. So when I add these together, this is the function I get. Now, because this is a parabola, it's an x squared, if you were to graph it, you're going to get a parabola, there's no x values that don't work, which means your domain is going to be all real numbers. Now, if you're subtracting, this is really where your parentheses are important. So h of x minus f of x. Now, h of x is x plus 2 minus f of x, which is x squared minus 8x plus 4. Now, many students on this one will get a wrong answer because of these two terms here. They'll see there's an x squared here but not one here, and they'll put positive x squared, which is not the case. Or this one, they'll see this negative 8 and they'll combine it with 1 to get negative 7x, which is also wrong. The easiest way to avoid those mistakes is to distribute your negative. We have x plus 2 minus x squared plus 8x minus 4. Because we're subtracting this whole expression, so we're subtracting every term inside. So what we really get is negative x squared. Combine the x's to get positive 9x, and then 2 minus 4 gives me negative 2. Now, just like the previous one, this is a quadratic function, which is a parabola, and there is no restriction in the domain. You're going to have all x's giving you a y value. Now this one, h times g of x, well, h of x, okay, put this over here so we can see it, h of x is x plus 2, and g of x is 4x minus 3. So what you have to do on this one is either FOIL or use the box. So I'm going to FOIL on this one. First, multiply x and 4x to get 4x squared. Outside, you get negative 3x. Inside, you get positive 8x. And last, you get negative 6. Combine like terms, and you'll get 4x squared plus 5x minus 6. And because this is also a parabola, all your x's will give you a y. So domain is also all real numbers. Now, the next two are division. So f over h of x. So this means I'm going to take x squared minus 8x plus 4 over h of x, which is x plus 2. First, always look to see if you can factor or reduce it. But in this one, if I try to find two numbers that multiply to be 4 but add to be negative 8, I'm not going to come up with anything. So I can't factor this, which means this is as much as I can do on this problem. However, we cannot divide by 0. Which means your denominator, x plus 2, cannot be equal to 0. So what you have to do is find what value will make the denominator equal to 0, and that is your restriction in your domain. It's the x value that cannot work because it makes you divide by 0. So in this case, if I subtract 2 from both sides, it means x cannot be equal to 2, or negative 2, I'm sorry, which means the domain is any x except negative 2. There we go. A little bit messy, but you got the idea. All right. So let me show you another one just to make sure you got it. H over g of x. So h of x is x plus 2 over g of x, which is 4x minus 3. Now neither of these are factorable, and I can't reduce this. Nothing's going to cancel out. So I can't do anything more to that part of it. But my denominator, 4x minus 3, cannot be equal to 0. So I set it equal to 0 and solve for x by starting by adding 3 and then dividing by 4, which means when I go to define my domain, it's any x except 3 over 4. Now, with functions, you can also evaluate functions for a specific number. So for instance, if I had h of 1, what that means is in h of x, anywhere there's an x, I plug in a 1. So h of 1 would be 1 plus 2, or 3. You can do something similar with operations of functions, and there's more than one way you can go about it. So let's take two new functions. And first, I'm going to show you two ways you can do it on the first one, and then go from there. Now, one way you can do it is to actually combine your functions first, and then plug in the number. So that's the first one I'm going to show you. So if I were to take 2x squared minus x minus 12, and add to that x plus 7, I would get 2x squared, the x's would cancel, and I'd get minus 5. So then what I would do is I would plug in the negative 2. Okay, so negative 2 squared is 4, times 2 is 8, 8 minus 5 is 3. That's one way I can do this. You can also do it this way. Plug in negative 2 into f of x. We get 2 times negative 2 squared minus negative 2 minus 12. This part gives me negative 2. Then plug negative 2 into g of x, which would give me negative 2 plus 7, which is 5. And then add them together, negative 2 plus 5 gives me 3. Both of these work the same way, and if it's something small like the addition or subtraction, it's really about the same amount of work. Some of the more complicated ones, though, might be easier if you plug them in first and then combine the results. So let's take a look at this next one. I'm going to work it out the second method because many times it is easier. So f minus g of 8 means I'm going to take f of 8, plug in 8 anywhere I see an x in this function. So 2 times 8 squared minus 8 minus 12 gives me 108. Do the same thing for g of x, and we're plugging in an 8 for x. So x plus 7 means I'm going to do 8 plus 7 to get 15. Now when you go to subtract, please make sure you pay attention to the order, because it does matter. F of x comes first, then g of x. So I'm going to get positive 93. If it was g minus f, it'd be a negative 93. So make sure you are paying attention to the order. Right? So multiplying, same process. Find f of negative 1. Anywhere there was an x, you're going to plug in a negative 1. When you're doing these, please be careful about plugging in negatives, especially when you have squares or subtraction, because those are going to be easy sources of mistakes. Negative 1 squared is positive 1 times 2 is positive 2. Many people, if they don't put the negative 1 parentheses, aren't going to get a positive 2. Also, you're subtracting a negative, which means you're adding 1 here. So just be careful of your negatives. Now on this one we're going to get, so that's 2 plus 1 is 3, minus 12 is negative 9. For g of negative 1, same process, plug in a negative 1 for x, and then plus 7 gives me 6. And negative 9 times 6 gives me 54. Or negative 54, I'm sorry. Forgot my negative. F over g of 5, similar process. So we plug in the 5 into f of x. 2 times 5 squared minus 5 minus 12 gives me 33. G of 5, that's 5 plus 7 to give me 12. F over g, 33 over 12, reduces to 11/4 or 2.75. Alright, so these are most of the ways you can combine two functions. I'm going to do the other way you can combine functions in a separate video. So that's it for this one. Have a nice day, and